Okay, so now that we have our points established here, I want to go through the process of modifying them. So they currently are grouped into, um, they're grouped into rows, essentially, which is going to be kind of difficult to work with. So basically, every single one of these rows is going to be a different set. All right, so that first one didn't have anything in it, nothing in it, and then it continues on and it says 0, 0, 1, 0, 1, 2, so on and so forth. So these are each individual row, right? So that's 1, that's 0, 1, that's 0, 1, 2, 3, 4, or 0, 1, 2, 3, I should say. So we need to figure out basically how we want to structure the derivation of scaling. Okay, so I could have it evenly scale from the zeros all the way up to whatever the last number is in the list. And that's perfectly fine. So let's start with that and then see how we might be able to modify it to make something that's a little more interesting. So under transform and affine and scale, the geometry I'm going to scale is going to be the circles themselves. The center point is going to be the center point of the circles themselves. So that would be these right here. And just verify that they're all being scaled in their current location. And then the scale factor is essentially going to be done with a range. Okay, and the range is going to be defined by what our maximum values are. So the key is to figure out if you want it to be fully parametric, right? Fully parametric is the key. The key is to figure out whether or not list length is going to read the list of the rows or the length of all the items in that particular list as a whole. So when I go to set and list, I can read list length off of either the points or the circles. It doesn't really matter all that much. I'll just use the points right now. So I'm going to plug this in here and read my output and see what that output is. So what's happening is every single one of those rows is reading 0, 0, and then 0. The next set is 1, because it has one item in that particular set. And the next set has 2 items, and then 3 items, and then 4 items, so on and so forth. So this probably won't work for us, because if I do a range, it's going to create a range for every single one of those sets. So if I do a range from, say, a ½ inch to 2 inches, and there are only 2 items in there, well, then my 2 items are going to be a ½ inch and a 2 inch, which is kind of difficult to work with. It could also be appropriate, so I'll show you what that looks like in terms of generating it, but basically all of our highest values are going to be around the perimeter here, wherever our highest indices were. So let's do that by generating a range. So I'm going to go to sequence and a range of numbers. And so we have a domain, and then we have the number of steps. And so the domain is going to be the size, right? The variables of how many types of, or what range of sizes we can have. And the number of steps is going to be how many items do we have in each of these lists. I think there's a way to read the highest number somewhere. Rather than trying to read the highest number, there's a better way of doing it. So basically, if I go back to the number of subdivisions I have, then the v count is going to be the highest possible number of indices that I could have there. +1, technically. But I'm pretty sure the way that it broke everything down, I only have tens. So I'm going to use that number. So I'm going to use 11 steps, and I have to construct a domain. Okay, so I'm going to do that under math and domain using construct domain. So this domain, I'm going to use static numbers. So I'll just do 2 panels. And I'm going to start off with I'll go from 0.25 inches to 1.5 inches. I'll work from there and then we'll see how it looks. Now I also need to make sure that I convert this down 2 inches by adding an expression. So I'll do that now with this. I'm just going to say x divided by 12 and then x divided by 12. So 0.25, 125 maximum, or 1.5 maximum. And so that's my range of numbers. So when this gets applied, it's basically just going to read through this range of numbers. Actually, oh, I know what I want to do. Okay, so this creates a static range of numbers, which means it's just going to start at 0 and it's going to apply it to all of your numbers in the order that you've defined it as. So I'm going to turn this circle off so that you can just see the modification here when I plug it in. So when I take this range and I plug it in, oh, that made them really small. Oh, that's right, because these are very, very, quarter inch is very small. I forget how big this thing is. How big did I make it? Oh, I made it almost 50 feet wide. Okay, so let's up this. I'm going to go from 1 inch to 6 inches. It's probably a little more appropriate. There we go. That's a little better. So with this range of numbers, right? So 0.083 was the smallest one at 1 inch. And so when you read the scale factors here, the geometry is being applied sort of multiple times to every single one. So notice how this last element, see how that last element has a number of circles? It's basically saying that this static range of 11 numbers, or 12 numbers actually, is going to apply to each of those lists of points for the circle scales, but once it gets to the last one, it takes the remainder of numbers and just scales it that many times. Okay, so we need to go back and make this number of steps value something that's more appropriate and parametric to what we have. So essentially, if we use this list length, that's going to give us a number value that will be appropriate. Now, the way that the pattern works is going to be a little different. But anyway, so we have 0, 0, 1, 2, 3, 4. But be aware that when we say 0, 0, or when we say a value of 1, that's going to give us 1 step, which means it's going to give us 2 numbers. So there might still be some issues with it. So let's plug that in. And now you can see that what's happening is it's taking the smallest one, and then it's giving you that plus 1 extra value at the end. Is that clear why it's doing that to you? Is that clear to you guys why it's doing that?
Yes,
let's see. I'm trying to find a graphic that I can pull up on line. All right, so this is a good graphic. I'll pull this up. Something like this. Let me find something simpler. Here we go. So basically, this is kind of what's happening. We have 1 point on the end. The next one we have 2 points. The next one we have 3 points. It's basically this one, the one at the end, right? So 1 point, 2 point, 3 points, 4 points, so on. When we create a range of numbers, okay, the range of numbers is done by using a boundary. So a step has to have a minimum and a maximum value. So when you say a value of 1, meaning that you only want one number, it's actually giving you it's giving you a boundary for that number. So you essentially need to subtract out one of those values if you're going to do it that way. And I'm trying to think of did that make more sense?
Yeah.
Okay. It's good to see it in graphic form. So I'm trying to think of the best way to do this. Maybe range isn't what we want. Series is probably going to be better because it specifies the number of values in the series. Does that make sense? So basically, with series, you define a starting value, and you set a static distance or magnitude from one step to the other. So if there's only one value, then that one value just is your starting value. Does that make sense? So the way I'm going to do this for series, if I want it to have a similar relationship to the number 11 as a maximum, I'm essentially going to take my starting value, which is going to be 1 inch, and the step size for each number is going to be my maximum value, which is 6, and it's going to be 6 divided by 11 would be right, right? There's 11 divided by 6. 11 divided by... Yeah, 6 divided by 11 I think would be it. Yeah, let's do it that way. So math operators, do a division. So I'll do 11 divided by 6, which gives me 1.83. No, I lied. 6 divided by 11 is what I want. Yeah, which gives me 0.545. So it's about a half an inch each step. Does that make sense? So I can get rid of this now. This plugs into my step size. And then I just need to define the number of values in the series. And so this is going to take the place of range. So the number of values is that. And so what I get now, when you look at the panel, is a series of growth numbers, right? So the smaller lists, all the lists start at 1, which is our minimum value. Then it grows by 0.54 every time. So then it goes to 1.54, 2.09, 2.63, keeps growing, keeps growing, keeps growing. Make sense? Yay? Nay? Do you guys understand the difference between series and range? It'll take some practice. This might be one that I suggest you do again. But anyway, so I'm going to get rid of range. I'm going to go up here and plug this into the scale factor, and you'll see that, well, it's working, but we'll have to reduce the overall maximum value. So I'm going to change my minimum to a 0.5. I'm going to change my maximum to maybe 4 inches. Oh, it's got to go even less, 2 inches. Oy, even less. 1.75. Oops. Dang. 1.5. There we go. Okay. So that is the way I'm doing that particular pattern. Is that clear? All right. So I'm going to stop this video where it is here. I'll give you a chance to get caught up, ask any kind of adjacent questions before we move on.
Can you zoom out a little bit?
Yes.